In this video, we're going to talk about the difference between streamlines, streaklines, and pathlines. So let's first talk about pathlines. And the pathlines for a flow of fluid is basically a line traced by a given particle as it flows from one point to another. Now this definition might be too complicated, so let's make it simpler. And let's say there is a classroom and you are the particle, and let's say you have to go to the restroom. The path line is basically the path you take as you're going to this restroom. Now let's talk about a streakline. So instead of just you, let's say all of you and your classmates are going to the cafeteria since it's lunchtime, right? And so all of you guys, 1, 2, 3, 4, 5, let's just say all of you guys are going to the cafeteria in this direction, in this path. And a formal definition of the streak line is the line created by particles in a flow that have previously passed through a common point. So in our example, the streak line is we all start from the classroom and try to go to the cafeteria, and the path that we all take is the streak line. Now let's talk about the streamline. The formal definition of a streamline is a line tangent to the velocity field. Now that might be too complicated, so let's make it more simpler. And say you are leaving the school because classes have ended. And so let's say the path to get to the exit is here, and the classroom is here, and let's say this is you. Now, streamline is a line tangent to the velocity field. So instead of saying the tangent to the velocity, let's say that it's basically your line of sight, right? You want to take maybe a path going this way, and your line of sight is tangent to the velocity field as you're going to this way. So if you're in this spot, you're looking at this way. If you're in this spot, maybe you're looking ahead like this. If you're in this spot, you're looking ahead like this. This spot here, ahead like that. This spot like this, here. And if we just keep connecting all these lines, we will get our streamline. Now all three of them are the same when there is a steady flow. Now, for example, let's say we're at the classroom again, and we're heading to the cafeteria. And let's say there is some narrow hallway, right? And we are all trying to get this way in a straight single file line. There is no interruptions whatsoever. So everyone is looking ahead in this direction. So the streamline is the same. Each person's path is this way, and collectively everyone's path is the same. So this is a steady flow. Now the streamline, streak line, and the path line are different when there is an unsteady flow. Now let's take that classroom. Let's say there's another narrow hallway again, and this is the cafeteria. And let's say we are all heading to the cafeteria again, right? Somehow in this direction. But then there is another person going this way. Now, the problem with this is that as the person is going this way, as an example, as the person is going this way, everyone tends to move out of the way, as an example, right? And let's say as they're moving in this position, let's say instead of there, now on another time as they're moving, they're over here, everyone's moving out of the way here, they're still going this way, right? So as we look at maybe a specific spot over here, the people in this part, say they're looking kind of in this direction, let's say in this direction, and the person here may be looking at this direction, the person here looking at this direction, and the person here looking at this direction. Their streamlines are all different, and let's say the path this person is taking is going this way, the path this person is taking is this way, the path this person is taking this way. It's also different for all three instances, and the general trend is this way here, it's going this way here, and it looks like this here. It's all different, and therefore the flow is unsteady.